Welcome to Programming with Python session 13. Before we move ahead with the content of today's session, I would like to introduce to our website technolearnit.com. As you see here, you can go through this website to get more details about us, and you can also get to this web page. And if you want to contact us, you can use different means that are mentioned on this page. I would strongly suggest you to subscribe to this channels and follow us for more updates. Most importantly, for the people who are attending this session probably for the first time, this page is very important for you. So far, whatever sessions we have been conducted and the resources that have been used during the sessions, those have been uploaded here. These are downloadable resources. So you can download these at any point of time and practice them, and you can become a better Python programmer. All right. And on the same page, you will also have the information about when will be the next live session scheduled. So I would suggest you to keep an eye on this page and be up to date with the latest information about the live sessions and also the learning resources. With that said, I would also like you to subscribe to this Technolearnit YouTube channel. In addition to the live sessions, you will also be getting the daily quizzes based on Python concepts that we have already covered in our sessions. So this gives you an opportunity to be in touch with the concepts that we have discussed, and you can also be become more professional at such quiz questions. And these questions will really or thought-provoking questions, and you will also be getting ready to the interviews that you probably face in future. All right. So this is all about our YouTube channel, and I request you to subscribe to this. With that said, let us move on to our today's session. Well, today we are going to discuss sets. Okay. So let us take an example of this class of students as you see in this picture, right? So what if I have to store the roll numbers of the students participated in sports? Okay, I would like to store the roll numbers of the students. So there is a typo on roll numbers, roll. Sorry about that. So if I have to store the roll numbers of the students who participated in sports, right? That is my objective. For that, you may come up with different solutions. You may think of using lists for that. So in this list, as you see, roll number 101 has been repeated. Or if you want to go with tuple, of course, you can also use tuple for that. This is other way of dealing with it, right? So, but what if you want to maintain only the unique numbers, meaning you don't want to repeat the roll numbers, because I just want to decide whether a student with such a roll number has been part of sports or not, at least once. That's all. I don't want to count how many times he or she has been part of sports. I just want to check the participation of a student with a given roll number, whether she or he has been part of the sports. That is what my requirement is. For that, we should use sets. And let us take more examples and understand what a set is. Before we move ahead for practical session, a set is nothing but a collection of items stored in a single variable, just like any other data structure that we have been discussing in past three sessions, like list, tuple, all that, right? Similarly, it is a built-in data structure, and most importantly, this is unordered data structure, meaning the insertion order may not be preserved or maintained. So the items that you add or insert into a set may not maintain an ordering sequence. Okay, that is very important difference, right? And also the primary distinguishing factor between the other data structures with this set is that all the elements or all the items within a set are always unique. So uniqueness is a main property of a set. indicating it doesn't allow you to store duplicate items within itself, right? And of course, it is a mutable data structure, mutable collection otherwise, meaning you can add or remove or update items from a set. All right. And indexing on items is not supported. The reason being the ordering is not maintained, hence indexing doesn't make any sense on sets. And the set is represented using flower braces with each item separated by comma within it. Okay, and set allows us for faster searching of items. All right, now let us look at syntax and examples. So if you see this, you have set name, a variable name, equal to, and you have to use flower braces, and all the items have to be separated by comma. So an example here, if you want to maintain the roll number of the students who have participated in sports at least once, okay, and you don't want to really repeat the roll numbers if the same student with the roll number has appeared for sports more than once. That is the objective here. For that, you can use roll numbers as a name of the set or the name of the variable, and you can continue to store the roll numbers in it. Similarly, of course, the attendance. Again, this is again not a most suitable example because two students can have the same number of days as attendance in a month, but you don't want to maintain that. I just want to see how many unique days any student has attended. In such cases, you can use a set like this, right? You see all the elements within this set are unique. No element has been repeated. Similarly, if you want to store the distinct heights or unique heights of the students, you can use, sorry, I had to, there is a typo again here. The set symbol has to be changed on heights. Okay, same thing with promoted. You just want to store some boolean values. There are only two boolean values. So here also there is a typo with the symbol. Please make a note of it and change it to flower brackets. Similarly, the name here also the typo. Wherever you see common braces, you just change them to flower braces. You interpret that those are flower braces. All right. Similarly, a set can also allow to store different types of data within it. So you can store one integer, one float, one boolean, and one string type of data within the same set. All right. With that said, let us go to a practical session and understand how to create a set first of all. For that, I am going to use IDLE. So how to create a set? So I say set1 is a variable name, and one thing you can use is the flower braces, right? So you can just type in 1, 2, 3, 4. Okay, and I have stored 4 items within this set. Now you can ask for the type of set1. What is the type of the variable set1? It is nothing but set type. All right, this is how you can construct a set using flower braces. Then I may create a number of sets, any number of sets. Okay, so as you can see here, I'm going to store some random numbers here. So set the numbers can be given in any order, right? So you can give all this stuff, and now if you print set 2, you can see the order of elements has been changed. That is not exactly same as the order in which I have inserted or added the elements within the set. This is quite possible on sets. The reason being, set will not maintain the ordering is what we have already seen. The reason being, set stores these values in a hashed, using hashing, all the set elements will be stored. So when you hash an item, you may get some specific number. Based on that, it decides what element or what item to be stored where. So there is no guarantee to maintain the order of elements when you create a set. This is very evident with this example, right? This is how you can create a set. And how do you create an empty set? If you have to create an empty set, is this what you need to do? Can you create an empty set like this? Right? Let us check. What would be the type of set 3 now? Interestingly, it becomes a dictionary. If you remember, for a dictionary also we use the same symbol, right? So this is not the way to create an empty set. So to create an empty set, you should use like this. Now, if you ask for type of set 3, it becomes type set, right? So it is a very, very distinguishing difference. Don't just use flower braces to create an empty set, a pair of flower braces, but use the name set and followed by braces. Okay, this is how you can create an empty set. All right. Now you can also create set using that is set construct and a list. For example, I am going to create some set with some numbers. So if you now ask for the type of set 4, you get it as a set. And if you print set 4, this is how you can see, right? And here the ordering has been maintained, but it is not guaranteed at all. That's what I have given, I shown you in the earlier example in the case of set 2. So there is no guarantee that the items ordering is maintained. Keep that in mind always when you are dealing with sets. All right, how to create a set with flower braces is what you've already seen. Similarly, how to create a set with set using the name set and using a list. I have shown you how to create an empty set is also what we have covered. So moving on to the next topic, which is nothing but adding items to set. Okay. So how do you add more and more items to an existing set is what we are going to explore now. So let us take a set 5 with just empty. So if you look at the type of set 5, obviously it would be a set. And if you print set 5, you don't get anything because it doesn't have any data within it, right? Now, how do you start adding items to this? For that, you can use add. Now, if you look at set 5, what is there in set 5? You got a single element in it. You can also use print function and pass set 5 to this and you will get the same output. All right, let me add one more item to this set. So here set that you should use is add, and I'm going to add 11 to this. Well, look at set 5 now. Yes. Now set 5 got two elements. So this is how you can keep adding more and more elements using the method set. I'm going to add 85. I'm going to add one more. So using this, you can read the user input and keep adding the items to set as well. So if you look at this, we have started with an empty set and gradually we have been adding one item at a time to this set. Make sense? And yeah, you can of course use print also now and you can get the same response. So this is how add is a method used to add more items to a set. All right. Now I'll start with some set which already has some values. I need not really start with an empty set as in the earlier example, but in this case also I can keep adding more and more elements to this. Let me add a 10 to this. Yes, that is quite possible. And this is how you can see you got this item 10 added to the existing set 6, right? So this is how we can keep adding more and more items to an existing set using the method add. with that said, let us move on. How do we add multiple items to an existing set is a next topic. So far, if you look at how I have been adding the items to the set, I have been using add method and I have been passing only one item at a time to this add. So if I have to add 10 items, I have to call this add function 10 times, correct? But what if I have to add more elements to the set? For that, you can use a method called update. So let us add more elements to this in one go. For that, you can use update method. And for this update method, you need to pass a list. So I will just add more elements to this. Okay. So now 6 is not defined. Oh, sorry, set 6. No, the name was wrong. Yes, I'll use the same items 6, 5, 9, and 0. And if you now print set 6, you can see that this is set got all the items that were already present plus the items that you have just updated. So this is how you can just do a update operation so that you can add more items in one go to an existing set, right? So you can either use add or update based on the situation. If it is just one item you know to add to a set at this point of time, just go ahead with add. Or if you have more items with you, more than one item with you, and just have the notation of list to that and then call update function, sorry, update method to add all those items in one go. That is how you can use update. All right. Now let us look at set 5. What is the content of set 5? Okay, set 5 has this, set 6 has this. Okay. And now if I have to add all the items of set 6 to set 5, you can do it in one go using the same update method. For this update method, you can pass as set 6 as argument. So what did I pass to update method now? Earlier I was passing a list as argument to update. Now I am passing the set type of object to update. So now if you look at set 5, you see all the items that were already present in set 5. You can see all these items 11, 12, 85, 44. You can see all of them existing plus whatever have been there in set 6, all these items you can also see existing in this set. So all those things have come, all the items have come and they have been added to set 5. Like this, you can either pass another set that was already existing or you can pass a list of items to update method to add more than one item at a time to an existing set. All right. With that said, let's move on. The membership operators again. Yes. So if you look at this set 5, there are certain integers or certain items within this. So if I have to know if 3 is in set 5, 3 in set 5 is what you need to use and it returns true because 3 is present. 3 is a member or what we call 3 belongs to set 5 is what we call mathematically. So 3 belongs to set 5 or 3 is present in set 5, hence you get true as output. Let me check if 55 is in this set 5. It gives you false because I don't see 55 within these items. Hence 55 does not belong to set 5. Hence you will be getting false as output. Similarly, 55 not in set 5 would give you true, because you have used not here, not in membership operator is what you have used. Hence, 55 not in set 5 would be true. Similarly, 3 not in set 5 gives you false. All right. So this is all about membership operators, and not only integers. I have been dealing with integers only in all my examples so far, but sets allow to store different types of data. I was showing you on the slide. For example, I'm going to store some float values. Okay. Yes, this is how you can create a set with float type. So I am going to create a set with strings now. Maybe I'm just giving some city names. Yes, type of set 8 is a set. So you can create a set with integer items, float items, or string items as you see here. You can also create a set with boolean items, true, false. You can validate if set 9 type is set or not. Yes, it is a set. All right. So this is how you can create a set with the booleans. And now I'm going to show you to create a set with all types of data, different types of data. I should not say all types of data, but I have one true. I have also one string, or I can even add more um, strings as well if required. And I also add the second boolean value, and I will also add one more string, right? So what I did here, I have created a set with the different types of data. Quite possible, right? Yes, this is also a type set. And if you print the value of set 10, you can get all these values. But as I said, there is no guarantee of maintaining the ordering. Hence, you cannot use indexing also. So if you ask for set, what is there in first index of set 1, you will get set object is not subscriptable. That means indexing is not possible. Hence, you cannot just use subscript operator on set. Makes sense. So the membership operator. And now, if you want to know if Chetan is in set 10, yet yes, it is true because set 10 has Chetan, or Chetan, the string Chetan belongs to set 10, right? And if you want to check if Abhay is in set 10, this is how you have to check, and you'll get false because the string Abhay is not part of set 10. All right. This is how you have to use membership operators on sets. The next one is update with another set, is what I have already covered in my earlier explanation, where I have been using update to, yes, I have been adding update to add more elements to this set, and I'm passing a different set as argument to that. So let's move on. The next one is about removing items from set. So since set is a mutable collection, I have shown you how to add items to an existing set. I have also shown you how to update an existing set, right? With a new, by adding new elements to that, right? Now, how do we really remove items from a set? So again, let us take an example here. What is a set having more elements in it? Yeah, set 5 is another example I would take. So set 5 has these elements as right now. And if I have to remove, for example, 10, the item 10 from this, you can use set 5 dot remove. Remove is a method, and you can delete, can remove 10. And now if you examine the values within set 5, you don't see 10 present in this set. So the 10 doesn't belong to set 5 at this point of time after this remove operation has been performed on this set. Make sense? Let us also assume set5 dot remove. I'm going to remove 5. Okay, and you can also check the value now of the set 5. You don't see 5 existing in this set. 5 doesn't belong to this set. Okay, and what if I try to remove some non-existing element like 99? 99 is not does not belong to this set 5, but I'm trying to remove it. See what happens. You will be getting an error. Which is, what is that error? It is a key error. It is key error. So if you have to remove an item from a set, one way is to first check the membership of that using membership operator. If 99 in set 5, then you can call remove function. Otherwise, if you don't want to do all that, there is one alternative for that, which is discard. So this discard method doesn't throw an error even if the element that you pass it to that method is not does not belong to that set. So that is a key difference between discard and remove. Remove on the set, the remove method of the set throws an error which is a key error when the argument that you pass to that remove does not belong to the set. Whereas discard method doesn't throw you an error, but it would be quiet. It doesn't do anything because it did not find that item within that set. So there is nothing to delete. So it will just be calm. And you can see the same items repeated in the set when you print it again. Because there is no effect of this discard because it has checked, but it could not do anything since it did not find the item 99 within the set. This is the key difference between remove and discard. Again, this is an important interview question. What is the difference between remove and discard? Or when I try to remove a non-existing item from a set, I get an error. How to get rid of it? There are two options for you. One is to you explicitly check whether the item that you are about to remove belongs to that set before even you attempt the remove using if condition and also membership operator in. The second approach is directly to change your method from remove to discard so that you won't get any error in case the argument that you pass to discard does not belong to the set. All right. So this is about removing items from the set. The next one is functions and methods that you use on sets. All right. Now, as usual, you can use length function, length, to find the number of items present in this set. So how many items do you have in this set? 5. You have 10 items is what it says. Let us count it quickly. Up to here 4, 5, 6, 7, 8, 9 and 10. Yes, there are 10 items or 10 elements within this set. So the len function returns you 10. Okay. Similarly, now one important thing is let us print the ID of set, right? ID of set 5. You will get some number. Now I'm going to add one item to this, one more item. Call it 72. Now if you look at set 5, you would see 72 added to your set. However, now look at the ID of set 5. What do you expect from this operation? You see the ID is same after you have performed the add operation. That means all these operations are in place on sets. So when you are doing any modifications on a set data structure or set object, the the operation is uh, in place operation. Hence the ID doesn't change. Similarly, if you remove something from this set, Okay, remove an item. Let me remove 11. You can see set 5 now. Yes, you don't have 11 over there. And if you print the ID of set 5, you will get the same ID. It maintains the same ID, meaning the object has been maintaining the same ID. That means it is all in place operation, right? This again proves that set is a mutable collection. Mutable collection means you can change it in place. All right. So this is about um, how you can confirm if a set is mutable or immutable, and by looking at the IDs, and you can try experiment with add and remove. These operations are allowed. It means it is a mutable collection, right? Now, for example, if you wanted to copy this to some other set, what if I say set 6 is set 5, and now you can see the same elements are now present in set 6, but if you look at ID of set 6, ID is the same. Both these variables have the same ID. That means you did not create a separate variable, but separate place to store the data, though the variable names are same. You have created a separate variable, but it also points to or maps to the same existing variable set 5. All right. What if I want to make a copy of it independently? Now what I'm going to show you is look at set 6 dot remove. I'm going to perform some remove operation. Let me remove 6 from this. Now let us look at set 6. Yes, 6 is removed from this as expected. Now look at set 5. Interestingly, 6 has been removed from set 5 as well. I have performed the operation on set 6, but how come set 5 got impacted because of this operation? The reason being the IDs are same for these two variables, meaning both these refer to the same entity. Hence, the operation you perform on one would obviously impact the other. If you add something to set 5, set 6 also will get that element within it, because both of these are pointing to the same object within the memory. So if you don't like this, if you want to maintain a separate copy and you want to perform some operations independently, then you can use say I'm going to create one more set, but I don't want to just assign what is there in set 5. For that you can use copy operation. So what you can do here is you can use set 5 dot copy method. Okay, now let us look at set 7. Yes, set 7 has this. What about set 5? Set 5 has these values, same values. Now I'm going to add something to set 7. I'm going to add 5. Now set 7 got this value. So you see 5 within set 7. Let us look at set 5 and check. Set 5 did not get 5 into it, right? That means even now you can check the IDs. ID of set 5 is something, and ID of set 7 is different. Hence, the change that you make on set 7 won't impact set 5, and vice versa as well. If you add or remove some items on set 5, there was no impact on set 7, because these are two different objects referring to two different places in the memory. Hence, in general, when you use this assignment operation, all that happens is a reference is created to an existing object. So any change that you make either on this or on this collection variable, the other one would be impacted. If you don't like that, you should use a method called copy and assign the result to different variables, so that these two will become independent variables. So the change you make on this won't impact this, and the change you make on this won't impact this. That is how you can perform the operations independently on both these sets. So len is one function you learned, and copy is the other function you learned. And I have been showing you add. Add is a method, right? Sorry, len is a function, but copy is a method because you are applying it on an object. So copy is a method, add is a method, remove is a method, discard is a method, right? Now let us look at something. What is there? Okay, S2 is there? No, S1. S1 is also not present. S5. Sorry, yes, set 3. Yeah, set 3 is empty anyways. Set 4. Yeah, set 4 got some values. Let me perform an operation on this. So if I have to remove all these items from this set, you can use here based on the number of items, based on the length of this set, you can call remove function by passing one element at a time. That is one way. Or in one go, if you have to, if you can delete these things, that would be helpful, right? So for that, you can use clear. So set 4 dot clear is what you can use. And now if you look at what is present in set 4, it becomes an empty set because all the items that you have wiped off from this set 4 now becomes empty. Okay, now if you look at length of set 4, it should give you 0 because there is not even a single element within this set. So clear is another method to be applied on set whenever required. So what is the difference between this clear function and the operation del? Del is for delete. Now I'm going to delete set 4. Now if you ask for set 4, you will be getting name error. The reason being delete will completely destroy this object from the memory, and you cannot refer to an object or the variable that is not present in the memory, hence you get name error. I don't know what this set 4 is what Python is saying in its error, right? Set 4 is not defined, right? So this is how you can either clear off all the items from a set, but you can retain the set with as an empty set. Or if you don't want to use that going forward, you can use del operation on that. You can use del operation on that. Okay, this is the difference between del and clear. All right, so these are the methods that we can come across the sets. There are other methods, but I'll be covering them under mathematical operations. Okay, so next one is mathematical operations only. So I'm going to cover couple of more methods as part of this discussion. So to understand these mathematical operations on sets, you need to understand some mathematical concepts. Set theory is a concept in mathematics. So all these operations are very much tied to that set theory. Hence, explaining that would be helpful. So I will just show you what these operations are. Assume that assume this is a set. Okay, so you also assume this is another set. So this set, for example, got 1, 2, 3, 4, 5. Assume. Ideally, I should put these values within this, but I am just adding here on the top. Okay, and this is set got 2, 5, 8, 9, and 6 also, of course. Okay, let us call this as set A. I'm just giving some names to these sets. I'm going to call this as B. Okay, right. Now there are certain operations that you can apply on these sets. and these are the members of these sets, or these are items within the set, right? Now, first thing, what if I have to club all the items within this set? First of all, if I have to club the items within this set, how does it look, right? How do I get all the items in? Sorry, I may create another set, and what is that I get into this? So let me use that same set notation only here also, which is most appropriate thing to do. Okay, this is how your sets are. Now I'm going to create another set. How can I do that? First thing I can do is I want to club all the items from this set, right? So first I got all the items from A, and then I just blindly add the items from B. Let us see what happens. 8, 9, and 6. Okay, but set actually supports only unique elements, right? But you see 2 repeated. So you can remove this from here. 5 is repeated. You can remove this from here. 8 is not repeated. 9 is unique. 6 is unique. 1, 2, 3, 4 also are unique within this set now. So this is called union operation. Union operation means getting unique elements from either of the sets and constructing a new set. Okay, now let us look at set. What was the earlier set? Big set? Set 5. Huh? Okay. Okay, right. Set 5 has all these items at this point of time. And what if I try to add an existing element to this? Say, let me add 0 again. It doesn't throw out an error. But if you see, nothing changed. So when you attempt to add an element again to a set which is already existing, nothing happens. That means the set will not have any change. It set will not undergo any change. All right, that is very clear. Similarly, if you go to this example, if you even try to add the same element within this, like again, the other example would be, I'm going to create set, right? Within this, I give the same item again. Let us see. And now look at set 11. It has only one item because the rest of all are duplicates. The rest all are repeated. So you get set is nothing but only unique values, right? It should contain only unique values. So this is what happens. Now this makes more sense, right? What I did blindly, I had just got all the elements from A. I got all the elements from B. Then I have checked if there are any repeated elements, just remove them. This is how you'll be getting a result of this result set as this. So what is this operation called? This is called union operation. Union operation defines uh, the resultant set, which is S here, as the elements within this union set should belong to either A or B. Okay, where is this one coming from? It's coming from A. Where is this 2 coming from? 2 comes from A, set A. 3 and 4 also come from set A, and of course 5 as well. 5 also comes from set A. And this 2 is not repeated because 2 is already covered from A. 5 is also covered from A, so no need to repeat that. 8, 8 is not part of A, so it would now come and be part of your result. 9 and 6 also same story. So let us try this operation now. I'll just take some different numbers, that's okay. I'm going to create set again. I'm going to overwrite an existing set even if it is present. Or let me call it as S1 to be simple. S1 has 1, 2, 3, 4, and 5 also. S2 has some of the elements I intentionally repeat. Yes. Right? Now look at S1. S1 has these values. S2 has these values. Perfect. Now S1 S1, if you have to really perform the union operation, the operator here is pipe symbol. S1 pipe S2. You see what happened in the result? Union operation is represented using pipe symbol. So you got a new set. 1, 2, 3, 4, 5 have come from set 1, and 6, 8, 9, only 6, 8, 10 have come from set 2. 2, 4 have not been repeated because set doesn't allow duplicate elements. So all these elements, how they have been constructed, if you just randomly pick one element, it either belongs to S1 or S2 or both. Even if it belongs to both, for example 4, you pick 4, 4 belongs to both of them, but you get it only once in your result. So this is your result, and you can store this in a separate set also, because when you perform union operation on two sets, you will get another set as a result. So now you can check S3. Yes, S3 is this. And is there any change in S1? No. Is there any change in S2? No. So how or whatever values that have been present in S1 and S2 before you attempted this operation, those items will continue to remain in those sets. That means S1 or S2 won't change. But since you have stored the union of these two sets in S3, S3 gets all the values into it. Make sense? This is one way of performing the union operation using operator pipe. The other way of doing the same is to use the function method s1 dot union and pass second set as argument to this. Now if you look at S4, that also gives you the union result, which is all the items that either belong to A or B or both. Makes sense? So this is a union operation. And interestingly, what happens if I perform union operation on the same set? For example, S1 dot union and I pass S1 only. Can you guess? I'll be getting same S1 only, right? Why? Because set doesn't allow duplicate values. It allows only unique elements. So when you union S1 with itself, you will be getting the same set as a result. Okay? That's what you have to understand. Now, this is one operation, and in Python, union is represented using pipe symbol, or you can use a dot union and pass b as argument in this example. Okay, either you can represent this as a or b, or you can use this alternative. All right, so this is one operation which is called union operation, represented by pipe symbol. If you want to use a method for that, yes, it is present. Union is the name of the method. All right, the next operation is intersection. So let us again take the same example, and intersection is a different operation than union. In a sense, intersection relies on the common elements between these two sets. Okay, look at this. One, is this common element? No, it is not. Why? Because one is not present in B, so it is not a common element between these two sets. What about two? Yes, 2 is present in set B as well. So 2 is a common element. So 2 will be part of your result of intersection. What about 3? 3 is not part of B, so 3 doesn't come into picture. What about 4? Yes, 4 is present in A. Sorry, 4 is present in A but not in B, so 4 cannot be part of result. When it comes to 5, yes, it is also present in second set B. So now this is called intersection operation. Intersection operation, right? So I will just call this new set as I. And how does it look like in this as per this example? It will have 2 and 5 as well, right? These are the only two elements that are common between these two sets. I am just explaining the concept using two sets, but this can be extended to more than two sets as well. But the theory, the concept is same. The rules are same, right? So that is about this. All right. Now, how do you represent this intersection. The intersection is represented using and symbol. So according to this example, you should write it like this. And if you want to use a method, you can use a dot, sorry, a dot intersection and pass the second set as argument. Okay, let us try this out. Again, S1 has these elements, S2 has these elements, and I'll store this result into S6, which is an intersection result, S1 intersection S2, right? This is operator, and look at S6. You got 2 and 4 because 2 and 4 are the only common items between these two sets, and that's what the result is, right? And if you want to use, sorry, S7 is equal to S1 dot intersection of S2, right? Now you check S7, that also would be the same, having the same result. So either you use operator or you use method. This is how intersection works on sets. Of course, the next operation, let's move on to the next one now. The next operation is a difference. The difference operation. So what is this difference operation? The difference operation, I would represent this as t, just, yeah. The difference operation. Again, the difference operation, if I have to represent this as a, and the difference operation is represented by using minus a symbol. Okay. And if you want to use a method, you can use difference and pass the second set. Okay, look at this carefully. When I ask for the difference, what it means is the item should be present in A but not in the second set, which is B. So what are such items? Tell me. One. One is present in A but not in B. So that is going to be added to the result. What about 2? 2 is present in A but it is also in B. So that cannot be part of the result. 3 is present in A but not in B. Hence B can be added here. What about 4? 4 is present in A, so you can add it, and not in B. Yes. 5 5 is present in A and B as well, so it cannot be part of the result. So you see the result is going to have 1, 3 and 4, right? So as you know, as you have already guessed, A minus B is not same as B minus A. Okay. How do you represent this? B dot difference, and you pass A as argument, right? What does B minus A give you? What does it mean? What does this mean first of all? B minus A means the item must be available in B but not in A. 2 cannot be part of the result. Why? 2 is in B. 2 is in set B. It is also in set A. So that cannot be part of this result. What about 5? 5 is present in B. It is also part in a part of A. It belongs to set A as well. What about 8? 8 is in just B but not in A. So that can be part of your result. What about 9? Yes, of course. Yes. What about 6? Yes, 6 is also going to be part of the result. So you see A minus B, okay, A minus B is this actually. B minus A is this. These two are not same. Whereas when it comes to union, A union B and B union A would be the same. Similar intersection also. A intersection B and B intersection A give you the same result, but difference is not going to produce the same result. Okay, commutative law, right? A plus B is equal to B plus A. It is commutative. So similarly, in the sets, union and intersection exhibit the commutative law while difference don't. Let's look at example again. So you have S1. Let us quickly print what is there in S1. S1 and S2. So what is S1 union S2? Okay, you got something. What is S2 union S1? You got the same result. And what is S1 intersection S2? You got some result. What is S2 intersection S1? You got the same result. Now let us work on difference. So S1 dot, okay, first let me show you the operator. So for difference, we should use minus, right? S1 minus S2, store it in S8 and print S8. S8 has nothing. Sorry. This is another interesting fact, right? When you find the difference between the set itself, you won't get any difference. Why is that? Because if you look at find the elements which are present in this but not present in this, you are saying that's not possible. So you'll be getting empty set. But there is a typo. That's why I got that result, empty set. And now you see S8. Now look at. That means 1 is present in S1 but not present in S2. 3 is present in S1 but not in S2. 5 is present in S1 and not in S2. Let us go and check that quickly. S1 has this 1, 2, and S2 also has, sorry, 1 is not present in S2. So 1 is the candidate to be part of result. 2 is here, 2 is also here. 3 is here but not here. So 3 can be part of the result. Yes. And 4 is here. It is also here. 5 is here. 5 is not here. So you got 5. That's all. So this is how you will be finding the difference between these two sets. And what if I ask for difference between S2 and S1? You see, you got a different result obviously because now you just keep looking at items that are present in S2 but not in S1. Hence, you get a different result. So S1 minus S2 is not same as S2 minus S1, whereas S1 union S2 is same as S2 union S1. S1 intersection S2 is the same as S2 intersection S1. So this is how you see all these properties coming out. All right, that's about the difference. And the next one is, and the last one, of course, on these operations, mathematical operations on sets is a symmetric difference. Okay. What is a symmetric difference? As you see here, I have written a minus b as well as b minus a, correct? So, first of all, for symmetric difference, the symbol used is the cap symbol. So, let us look at again S1 and S2, these are the values. S1, I am asking for symmetric difference, I need to use pipe symbol here, and S2 is what you need to use. And what is that you got here? Okay, so when you have asked for this is nothing but these elements plus these elements, right? These elements are coming from here, and these elements are also being part of this. That is a symmetric difference, meaning it is nothing but combining two sets. What are those sets? That is S1 minus S2 union S2 minus S1, right? So that is how you get this. So symmetric difference is just union of sets between two sets. What are those two sets? S1 minus S2 and S2 minus S1. Let us look at this document again. So first of all, symmetric difference, I'll call it as, I'll create another set here. Where can you guess what I would be getting from the symmetric difference of this? It is nothing but, first of all, let us understand what is A minus B. You already have that. 1, 3, 4. 1, 3, 4. Union is 5. Okay, and then b minus a. So b minus a, you already have the result, right? Yeah, 8 and 9 and 6. 8, 9 and 6. So what is this again? It is a union, no? So 1 would be coming, 3 would be coming, 4 would be coming, 8, 9 and 6 would be coming. So this is what the symmetric difference is. So finally, the symmetric difference between A and B sets is going to have these elements or these items, right? And the pipe symbol is what we use. So here, if you have to write it, you have to write it with pipe symbol. Is this is what you see? The result. The result is final result is this. Okay. And if you want to use a method, the equivalent method for this is a1 dot symmetric underscore difference of b, pass b as an argument. Let me show that as well here. S1 dot symmetric difference. Yes. This is what you get. It's the same thing, right? Here you have used the operator and here you have used the method. That's the only difference. All right. So these are different operations, mathematical operations that you can perform on sets. Okay, I have just been focusing on what these operations are and how the result would come and all. But what is a practical application of these operations, right? Where do you really apply in practical world? So there are so many examples here. I'll give you just one example to understand. Okay. So say for example, you can. I'm coming back to the same um, example of maintaining the roll numbers of the students. Say for example, this is set A represents the roll numbers of the students who have participated in volleyball game, and this set represents the roll numbers of the students who have participated in cricket. There are two games, right? This is a set of roll numbers who have participated in volleyball. This is a set of roll numbers who have participated in cricket, right? The same person can play both volleyball and cricket also, right? So that is where you can see some roll numbers being repeated. Who have played cricket? If I ask, you just give all these roll numbers. Who have played volleyball? You will give all these numbers. I will ask who have tell me the roll numbers of the students who played either volleyball or cricket. That is nothing but a union operation. I want the roll numbers of the students who have either played cricket or either played volleyball or cricket. The other way of asking is what is the roll number of students? What are the roll number of students who have played either cricket or volleyball? Either or. Then union is what you need to come to your mind. Makes sense. That is where union comes into picture. The other way of asking this is the other question would be tell me the students who have played both cricket and volleyball. Tell me the roll number of the students who have played both cricket and volleyball, both. Then you will be getting two roll numbers. These are the guys who have played both the games. See, this is how practically you can solve such problems if you can represent the data in the form of a set, right? And what is the difference? How can you express this difference in practical terms, right? Tell me the roll numbers of the students who have played cricket but not sorry. Tell me the roll numbers of the students who have played volleyball. A represents volleyball, that's why. Tell me the roll numbers of the students who have played volleyball but not cricket. What is the meaning of B minus A? Tell me the roll numbers of the students who have played cricket but not volleyball, right? This is how these operations can be applied on sets practically and answer such questions, right? So that is all about mathematical operations and how you solve such things. The next one is the traversing through items within a set. Another interesting one. To understand this traversal, you can solve so many other problems, right? You have to understand how to traverse. So you can say you can use for loop, right? The same mechanism that you use on any other collection. And I am just asking to print each item, get one item from the set and print it. So this is a items that are present in this set. Make sense, right? So to traverse through each item within a set, you should use this loop. This is to traverse through each item within a set. Okay. The next one is conversion between collections, another interesting topic. And how do I really convert one type of data into other among lists, tuples, and sets, right? Let us first take an example of list to set. I have already shown this, right? 1, 2, 6, 9, 3, 4. I got some set here. Now, if you ask for the type of list one, you will get it as list. I have used square brackets, and that makes this list one as list, right? And how do I convert this list into a set? So I want to store this as store this in set variable f11, right? So for that you have to use set and pass the list as argument. Now if you check the type of S11, it would be a set. So now you have converted a given list. You have constructed a set from a list, right? You did not convert the list into set actually because the list is still remain as a list, and you have just constructed a set based on a list, right? So this is, and if you look at S11, you can see all the flower braces and all coming out. So now you know how to convert a list, sorry, how to construct a set from a list. I should not say conversion, but because I did not really convert the entire list, list is still list type of object only, right? It is just constructing a set from a list. That is the right way to use, right word to use, right? Next, how do you convert or how do you construct a list from a set? You already have set as 11, and I want to construct a list from out of this. For that, you can say list to. I'm going to create a list, and you call like this. Now look at the list two. This is what you get, right? So what is a type of list two? It is list. So you now know how to construct a set from a list, and you also know how to construct a list from a set. Same thing goes with the tuple. I have a tuple 1, 6, 3, 7. All right. Now I'm going to construct the set by passing this tuple to this set as an argument. Look at the type of S12. It is a set. Print the elements, print the items. Yes, this is what you see. Now I want to construct a tuple from this set. So you need to pass this entire set to tuple. Now look at the type of T2. It is tuple type. And if you print T2, it is represented as tuple, and this is what the elements are, right? So from list to set and from tuple to set, from set to list, set to tuple, all the vice versa operations is what we have covered. So this is nothing but constructing sets from, it's not conversion, but it is a construction of set from other collections. All right. Next item is frozen set. Yes, very interesting. Sets are sets mutable or immutable in Python? Sets are mutable because they allow add method to add new elements. Okay, all these things are possible. If you want to have a set which is immutable, that is where frozen set comes into picture. To construct a frozen set, you have to use frozen set. Okay, FROZENSET, and you pass some list of values 1, 2, 3, 4, 5. Right? Look at the type of FS. It is frozen set. So frozen set is different class and set is a different class. Right? Okay. Um, if I print FS, it represents like this. Right? Now let me try to add another element to this. You see, it's an attribute error. Frozen set object has no attribute add. Why is that? It's not a normal set. It's a different category of set. Okay. And a frozen set is a set where you cannot go ahead and modify it once it is constructed. Right. So frozen set is a kind of mutable set. Okay. Now, what if I create fs1? Rest of all properties will remain same. Frozen set, and I'll give it some repeated values. See, does it allow repeated values? Shouldn't be, right? Because set should never allow duplicates. So if you try to create a frozen set with repeated values, only unique values will be considered and that frozen set will be constructed, but you cannot perform update operation. Let me try to do some update operation as well. Dot update. Okay, it's not possible. So all those operations that I have been showing, most of the edit operations, CRUD operations, meaning of course create is, there is a difference in creation of set and frozen set that and read is just, you can just pass both. There is many difference. For print you can pass both either normal set or frozen set, no problem. It's the same syntax and it would result in the same uh, um, it would produce the same output, right? And update update is allowed only on normal sets but not on frozen sets, right? Addition operation also, if you have to add new elements, that's only possible if a set is a normal set but not a frozen set. So where do I add or use frozen sets practically? So frozen set, one example I can see, again I always say this: weekdays. There is a fixed number of weekdays, right? You can give all of those weekdays as list to this frozen set. Sunday and Monday, blah blah blah. I'm not going to write all of them, but you can just maintain a weekdays as a frozen set because the weekdays is fixed and those are unique, of course. So this is how you can create a frozen set, and you can keep adding the names of the weekdays. And you cannot add any extra day to this now once you create a frozen set, and each and every element is unique, right? You can store month names or anything. So that is all about Frozenset, and it doesn't allow you to add or update elements once you create a Frozenset. Okay, now where do you use this? Why do I need a Frozenset to be present in Python? What is a practical implementation of this? Where can I use a Frozenset? Well, if you remember in the session where we covered the dictionaries, right? Dictionary is what? It's a collection. Again, it's a data structure. It's a built-in data structure within Python, a built-in collection. And a dictionary is basically maintains a key value. Each item within dictionary is a key value pair, right? So keys must be unique. If you remember, keys must be always unique in any dictionary. So can a set be a key? Can set take part of a key in a dictionary? It's not possible because set is mutable. Can a list be part of a key in a dictionary? No. Why? Because list is also mutable. Can a tuple be key within a dictionary? Yes, it is because tuple is immutable. Now, if you want to make a set to be part of a key, all that you need is a frozen set, but not a normal set. So, for example, I create one frozen set with all weekdays. I create another frozen set with names of the months. Now, these two frozen sets can now become the key of a dictionary. And for the first key, the value can be weekdays. And for the second set, if I have to add it in the dictionary, second set becomes a key, and the value can be month names or names of the months. Like that, you can maintain that dictionary with its key being frozen set. So that is where you can use frozen set. So if you want to create a dictionary now, before that, no, let me create one more frozen set. What is FS1 now? It has only two. Oh, okay. Okay, sorry. Weekdays is a frozen set, right? Okay, that is numbers, but okay. Okay, that also I can use anyways. Okay, so you see you have two frozen sets anyways. Now I'm going to dictionary create a dictionary out of this. D1 is equal to, what can I use? I can create FS1 as a key colon key value. Value I'll put as a string. What I say? I say numbers. Okay. And what about the second one? What is the key for the second item? I would say weekdays colon value is names of weekdays or names in weekdays, whatever it is. Okay. What is the type of D1? It is a dictionary, right? It is a dictionary. And D1, if I want to grab the value of FS1, you can see it gives numbers. D1 weekdays. It will give you names of weekdays. Right. So is it possible to create such kind of dictionary? I'm just going to create one more dictionary by using a normal set. I don't want to use this frozen set. I just want to show you that. Okay. I'll just give some string as okay, one is enough to show you as an example, right? You see, unhashable type set. Okay, unhashable type set. So you cannot use a set as a key in a dictionary while you can use a frozen set as a key in a dictionary. And that is a summary. All right, with that said, the practical problems on sets again, where all can I use these sets? I have already given you some examples. You maintain the data of a class, probably the roll numbers or the names of the students. And interestingly, if I have 20 students in a class, it is quite possible that some of the names are repeated, right? Two different students but having the same name. What if I want to know the unique names within that class? So you can store all the names of those students in a list, and you can pass that list to a set. Okay, using for example, unique names is equal to, you can pass that list of for example, list of names, list underscore names. If you pass like this, then you will be getting all the unique names coming out into this set. Unique names would become a set. List names is a list actually, but from that you can get all the unique names. Same thing. Whenever you get unique, you want uniqueness. You are looking for uniqueness. You want all the unique roll numbers, or unique heights within a class, or unique ranks. How many ranks are there all together, right? You want to get that. You don't know the background of how the ranking has been given, but you want to see how many unique ranks are there, A, B, C, or X, Y, Z, or A, E, O, whatever it is. So you can do all that stuff using these sets, right? And again, when you are working on any e-commerce website, it is quite common that you have to maintain the buying cart of a customer. In buying cart of a customer, an item can be added multiple times. I add, for example, I add a mouse with quantity 1, and I just go to other web pages on the e-commerce site, and I keep on adding more and more items. And I come across another mouse of the same. I come across the same mouse, and one way is to increase the quantity to that same mouse, or I would like to add another item to that, right? In such a situations, if you want to know what is the list of unique items that user has ordered for, set is the best option, because by its nature, set always maintains the unique items within itself, right? So that is where sets are very important, and all the mathematical operations that I have explained you, right? Practically, just you can Google and find out more resources on how these just you can focus on these four operations first, right? Then you will understand like what kind of real-time problems can be solved using this set theory and these operations that are also supported in Python. All right, and I just wanted to cover two things. One is a subset and superset, and three things actually: subset, superset, and disjoint set. So again, coming to my same diagram, these are called Venn diagrams because scientist Venn has invented this kind of pictorial representation of these sets. Okay, these are Venn diagrams. All right. Now, what if I have 1, 2, 3 in this set and 1, 2, 3, 4, 5 in this set, right? 1, 2, 3 is within this set, 1, 2, 3, 4, 5 is within this set. Then B is called superset of A because it has every element that is present in A plus it has more elements. Okay. So then whichever set has more elements, that becomes a superset, and whichever element set has lesser elements, that will become subset. But there is one more thing very importantly, that from the subset, every element that is present in subset must also be present in the superset. Then only we can call it as a superset to the other set. Okay. So that is the relationship between superset and subset. So for that, I am going to show you how it would be. The representation itself is interesting now if you are dealing with superset and subset. So now if you have to represent this, right? This has 1, 2, 3. And this has 1, 2, 3 somewhere. I need not maintain any order. So, right now you have every element that is present in A also in B. Now A becomes subset of B. To represent that, what we do is we just take this. And let me first change the color of this. Format shape, color, color. Sorry, this is here. No, fill. I'm putting a different color so that you will understand it better. So now, ring front. What happened? Right. So this is how you represent. And this, yeah, 1 2 3 can be mentioned here, or you can put 1 2 3 within this circle, meaning now this is a subset, and whatever is outside that will have extra items. You don't repeat 1 2 3 again within this periphery, but you will be mentioning only the leftover items like 5 8 6 and 9 outside. That is how you represent. So now this inner set becomes a subset, the outer set becomes superset. Okay, for that also we have functions. I'm going to talk about that in a minute. Just 2 minutes more is what I'm going to take your time. Okay, and the other example is a disjoint set. Disjoint set means here if A has 1 2 3 and B has completely different items, there is no overlap at all. Okay, then A and B become disjoint sets. Actually, in fact, these are the disjoint sets. The way I have represented this, I have represented them as disjoint sets actually, but actually this should be something like this. Okay, like this. So because there are some common elements, no, 2 and 5. So 2 and 5 will be represented in this common area, and the elements that belong to A but not belong to B, that will be represented in this area only, and the elements that belong to B but not A will be represented in this area only. Okay, and disjoint sets is just completely two different sets having no commonality, no common items between them. All right, let us go to practical session now. Again, I'm going to create one set with items 1 2 and 3, and another set with 4 5 and 6. There is no common element at all. So now I can ask, please tell me if s1 is disjoint. Set to yes, it says true, because there are no common items, right? Okay, and I create one more with 198. Now you ask, what about S1 and S3? Is S1 disjoint with respect to S3? We should say false. It should be written false. Why? Because there is one common element between S1 and S3. At least one common element is enough to make them non-disjoint, right? So that's why the result is false. So this is about disjoint sets. These are binary operations, meaning we could have at least two sets to apply this. Okay, and of course, S1 disjoint S1, what does it mean? What do you think? We ask about S1 disjoint with itself, right? Sorry, disjoint. I disjoint is, what is the mistake? Oh, sorry, I did not use the right name of the method. Is disjoint of S1 to itself, I'm asking. So it is false. This will never happen. No. The same set cannot be disjoint to itself. So S1 disjoint S1 is always false. Always, always. Okay. So again, you have S. Okay. I'll just create one. S5 is 1, 2, 3. S6 is just 2 and 3. So 2 and 3. Yes. Now S5 is superset, right? To S6, right? So you can ask for that. Okay, first thing you can ask is whether S2 is a subset. Is a subset with respect to S1. S2 dot is a subset S1. That results into false. Okay, now let me ask is a subset with respect to S2. Okay, so sorry, I should use S5 and S6. No, I was using a different set. Sorry about that. I should ask S5 dot is a subset with respect to S6. It is false because S5 is actually superset with respect to S6. No? So if you invert it like S6 dot is subset, and then you can pass S5 as well, and it should give you true. Yes. So this is how these things work. And S5, you can ask is S5 is superset with respect to S6. This should give you true because S5 is a superset to S6. So this is how subsets, supersets, and disjoint sets work. Okay. All right. This brings us to the end of today's session on sets. And before we wrap up, again, I would like to introduce you to this website, the official website of Technolearnit. And you can go through this. And if you want to get in touch with us, these are different options for you to choose from, and you can contact us. And I would strongly recommend you to subscribe to our channels on these social media platforms. And most importantly, the resources page for you. Uh, the resources used for each session will be uploaded here, and these can be freely downloaded. There is no subscription or there is no login required. You can download these resources for free and practice those and become better Python programmer. Also, the same web page will contain the information about when would be the next live session scheduled, when would be the next live session conducted. So you just refer to this page and be up to date with the information. With that said, and also one more thing, sorry about that. This is a page where you will be having. I would like to subscribe. I would like all of you to subscribe to this Technolearnit YouTube channel, where you will be getting all the live sessions available, and also every day on a daily basis we'll be posting the quizzes. So as you see here, these are all the quizzes that we have been posting for all the days, and every day you will be getting one quiz question, and it is just 26 seconds of duration, half less than half second. So I would encourage you to subscribe to this channel and get these notifications, and all these quiz questions would be based on the topics that we have already covered, so you can guess the answer. And I would also ask you to watch these quiz questions till the end, because the answer is inbuilt. Answer will be highlighted at the end of the play, so you can just guess the right answer, and you can validate if your guess is right or not if you can watch till end. As you see here, that's what happens, right? So this is how you can subscribe to this channel and get most of it. All right. With all that said, I would conclude today's session, and that's all. Stay tuned for our next session, and that's all for today. Take care. Bye.